All right, hopefully it's still visible. Awesomeness. We have the technology. Yeah, I'm going for a run later, so I haven't like washed my hair yet today, so my picture is less than awesome. All right, so yeah, hop onto the server. Yeah, I am wearing regular clothes, so, but and let me throw out a test question. So. All right, so I just fired up a test question just to get a baseline here. Good. All right, so yeah, you should have a box like that, and yeah, we got almost 100%. All right, so let's do some regular expressions. All right, so let me tag this. So on Canvas, there's that link which shows a quick synopsis of the parts of regular expressions that we talked about, which is, you know, a tiny subset, but basically dealing with anchors to put things at the beginning or end of a string, matching any character, matching successions of characters, and then putting things in registers, using those registers, matching things in brackets to say match any of these, and so on. So let's play with some of these patterns. So let's try the following. So let's just go ahead and try that first one. Let's write a regular expression to remove the first Q from a line. And you can just do this as a just show me the substitute. And we can pretend we're going to put that into sed or you know, after a colon in VI or something like that. All right, so mostly seeing two things. Um, Substitute q slash slash and substitute caret q slash slash. So this will remove a q if it's anchored right at the beginning of the input line. But that caret is anchoring it, so it's only going to remove a q if it's the first character on your input line. If you want to remove a q anywhere in there, then you'd want to do something like this. And that says, anywhere that you find the letter Q, replace it with nothing. And so that would remove it no matter where it is in the line. If you put a space in here, then it actually replaces that Q with a space. So I'll draw spaces like that usually. That would actually replace the Q with a space instead of just deleting it. And if you do a lowercase q, then it's going to match a lowercase q, because it's definitely case sensitive. If you do a g at the end, that would remove all occurrences of the letter q, or replace all occurrences of the letter q with a space, right? If you put a g over here, though, it would maybe remove consecutive Q's in the beginning. I don't think so. I think it'll just remove the first Q still. All right, cool. All right, so that's removing the first Q from a line. We already talked about removing all the Q's from a line. And then removing any occurrence of th from a line, well, that would pretty much be the same, right? Instead of q, you would just substitute th with nothing. But let's go ahead and try this next one. So yeah, this works with sed, bash, vi. It's all that sort of stuff. So regular expressions, yeah, they can go in with a colon. In VI, they can go in the argument that you put into sed. You can use them in Perl. There's lots of places we can use those. All right, so next question. Let's remove the first occurrence of the letter T followed by any character. So going through your string and there's a T followed by something, you want to remove those. So mainly seeing two types of answers here. Substitute slash t dot slash slash, or substitute slash t star slash slash, and a few variations in there. Substitute t star dot slash slash. All right, so this asterisk is saying whatever we're asking to match right before that, let's match 0 or more of those. So if I search for, say, an A star, that will match the letter A, it'll match 2 A's, it'll match a big long string of A's, it'll also match, nothing, an empty string, 0 occurrences of the letter A. So this would replace, any succession of the letter T's by nothing. So if we had a string with just a letter T in it, it would remove that. If we had 2 T's, it would remove both of them. If we had 5 T's in a row, it would remove all 5 of them. This one would remove, the first occurrence of T followed by all subsequent, T's right next to that first one. So any pattern of T's. And then whatever the next character is after that, that's what that dot would match. This one would remove the first occurrence of the letter T, and then whatever character comes after that. So that would take out the letter T followed by any single character after the T. And yeah, this works the same in Vim as it does in VI. In fact, we rarely run VI anymore. Usually when you say VI, it's linked to VIM or Vim Tiny or something like that. But yeah, all of this stuff works in VI as well. All right, so if you put the caret in the beginning, then you're only going to match if that T is the very first character of the line. So unless that's your goal, you don't want to put the caret in the beginning. And if you put the G at the end, then you're going to not just remove the first T followed by any character, but anywhere in the line that you have a T followed by another character, that would get removed. So only do the slash G if you want to do this multiple times in the line. Only do the caret if you want to anchor it into the beginning. All right, so good. Let's try another. So let's go ahead and remove the last character from a line. And if you came in late, we're using the answer command on the Linux server to answer questions about regular expressions. So hop onto the Linux server and go ahead and run the command answer. Wonder if I can use my boogie board. Trying to save the trees here. Maybe that works. Yeah, this is my budget Wacom. All right, so let's see. Looks pretty good. So I'm seeing three possibilities here: substitute dollar slash slash, substitute dot dollar slash slash, and substitute dollar dot slash slash. All right. So the dollar sign does not actually match a character. Okay, it's a different kind of thing. It's called an anchor, and it basically says whatever pattern you have matched up to this point has got to end at the end of the input string. So if there's nothing before the dollar sign, this would always match, but there'd be nothing that was being matched, right? It's matching the empty string, sort of the lambda at the end of the string, and so that wouldn't actually change anything. This period will match a single character, which we could do, anywhere in the line. But even though this would match, the first character, unless that's followed by the end of the line, the dot dollar sign is not going to match. But if your input string is something like ABC, then that dot is going to match the C, and the dollar sign is going to be associated with that end of line anchor. So this would do what we're after. This would say you need to be at the end of the line, and then there has to be a character after that, and that's never going to be satisfied. So yeah, the caret and the dollar sign are called anchors, and they basically say, caret says you have to start at the beginning of the line and then match this pattern. All right, cool. And yeah, this is I think it has a battery in it, but it's pretty passive. It's just pressure sensitive. I got it at Costco years ago for about 17 bucks, and you pop a little button up here and it just erases, and it's one color, and it's reflective. There's no backlight or anything, but it's nice for doodling. And just doing quick things. So yeah, maybe I can save a few trees like this. So yeah, generally caret would go before the thing you're trying to match, and dollar sign would go after, assuming you're looking for something in the beginning and the end of the line. All right, cool, awesome. And yeah, it's dollar sign for the anchor at the end. All right, let's see. Yeah, it's pretty cool. My favorite though is the Zen board. Have you ever played with one of those? It's basically like a stone and a paintbrush with water, and you can paint. And when you put water on it, it turns really really dark, right, like black ink. But the water evaporates after about a minute, and whatever you painted, disappears. So it's a nice exercise in impermanence, but still a chance to be creative. And it's like the sand paintings that the Buddhist monks come and do at the library when we're not locked down. And if you get a chance to see those, they're really amazing. Yeah, mandalas, thank you. All right, so all right, so this one's a small variation on the last one. Go ahead and remove the last three characters from an input line. So mostly seeing the right answer or pretty close to the right spirit. Substitute dot 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 dollar sign with just a slash slash nothing. So, you know, that matches any character, followed by any character, followed by any character, but then it has to be anchored at the end of the input, so that would remove the last three characters. So if you do a 3 dot, right, that's going to look for the character 3 followed by any character. And someone just suggested that, and I just tried that with set at least, and that does not seem to work. Although that may be the variety of regular expression, so I don't know if that's a thing or not. I'm guessing it is. But this will guaranteed work. Dot 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 dollar sign. And remember, our general pattern is, you know, put the old thing in, the thing that you're looking for, and then a slash, and then the thing that you want to replace it with. So in this case, it would be dot 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 dollar slash, and then the thing we're replacing it with is, you know, an empty string, just something between two slashes. All right, so let's play with registers. So registers are how we can get a hold of the things that are matching a pattern and then use them in the replacement string. And normally when we do this, you know, if we want to replace a character, we say substitute slash, you know, something, and then we have these parentheses to group an expression, and normally we have to put escapes, backslashes in front of these parentheses. So I'm going to suggest, for the sake of doing this today, let's not bother with those backslashes. Okay, let's just use parentheses to group things and not worry about it. So if I want to, you know, find the letter T followed by a character, but I want to throw that into a register, I'm just going to surround it by parentheses. Okay, so we don't have to go too extreme with the backslashes. This won't work in VI or SED directly. You need to put the backslash in front of the parens, but we're just going to skip those for simplicity's sake. So let's try the following. So let's swap the first two characters of an input line. I'm going to fiddle around with my lighting while you do that. All right, so it looks like we've got the right idea, which is basically to take the first two characters, match those with periods, put them into registers, and then use those registers in the right side of the replacement pattern. So the syntax of regular expressions is non-obvious, right, and takes some fiddling sometimes, but the goal people seem to have, which is take the first two characters, put them into registers, and then replace that with those two registers in the opposite order. So start with our S, right, to say substitute, and a pair of periods will match the first and second characters. Now, I could put an anchor in the beginning, but regular expressions always start from the beginning of the string. So the anchor is optional. I could put it in to be absolutely clear, but even without it, this will match the first character and this will match the second character. And then I want to replace it with the second character followed by the first character. All right, so a few details here. First of all, anything that we don't monkey with in the string stays exactly as it was. So if I take the first two characters and replace it with something else, characters 3, 4, 5 will still be the same as they were. But again, if we want to be absolutely explicit about this, we could also match the rest of the string and put that into another register. And I've seen some people doing that. All right, so let's nail the syntax for this. So I want to match the first character, put that into a register. We'll put parentheses around it. Again, when we do this in sed, we have to put in backslashes, but for working on these in class right now, we're skipping the backslashes. So put parentheses around the first one, put parentheses around the second. All right, now we've got the first two characters inside registers 1 and registers 2. And so we want to replace those with the contents of registers 2 followed by register 1. So to get the contents of a register, it's backslash register number, backslash register number. So that will do what we're after. Again, we could put a caret in the beginning, and we could put that caret outside or inside that first parenthesis. It's not going to make any difference, right? The parenthesis says everything that matches this. Well, if the caret's in there, right, the caret's not an actual character. It's just an anchor. So that would work either way. Let's see. So yeah, backslashes to match, to pull out a register number. We would not want to put a caret over here on the right side because the left side is a pattern we're trying to match. The right side is what we're replacing it by. So a caret or a dollar sign here, anchors our pattern to the beginning or end of a line. A caret or dollar sign over here is just a caret or a dollar sign, so it would just appear verbatim in the replaced text. And so if you wanted to do this a little more precisely, right, this would also work. This would match the first character, the second character, and then any succession of characters, and this would go into registers 1, 2, and 3. So when we replace it with register 2, register 1, register 3, what we're doing is putting this character first, followed by that, followed by the rest of the string. And so that would work really well. And again, we could put a caret in the beginning, we could put a dollar sign at the end. Why don't we need a dollar sign at the end? Because regular expressions are greedy. They will gobble up as much input as they possibly can. And so, a dot star would certainly match a single character, but if there's two characters side by side, that would also match this pattern, so we'll gobble up both of those. And in fact, if there's 12 characters from here to the end of the string, since all of those characters would match this, it'll gobble all of those up. And so all of those would end up in register 3. Cool. All right, so let's do this. So we can do A, B, C, D, E, F, G, and it swaps the first two characters. What's going to happen if I put in a single character? Well, I don't know if it replaced anything or not, but either way the result would be the same. And if you have two characters, I'm getting some strange stuff there. Okay, that was a typo on my part. And if I have an empty line, I'll just get back an empty line. Right, so the caret in the beginning doesn't affect anything. And a caret on the right-hand side becomes just a caret in the output pattern. All right, so now more challenging question, swap the first and last characters of a line. All right, cool. So again, you know, the basic idea, the strategy here is find the first character, put that in a register, find the last character, put that in a register, and then just, you know, put them in the replacement string in the opposite order. The trickier part about this, though, is dealing with the stuff in the middle. So if I say substitute, you know, beginning of line period, and then a period followed by the end of the line, right? This matches one character at the beginning, this matches one character at the end, but to match a pattern in a regular expression, we have to start at the beginning and match every single character in succession to the end of the pattern. So this would work for, you know, a two-character input string, but if we have something like ABC, this pattern will not match that string, right? Because the caret says we have to start at the beginning of the string. Well, the dot will match the letter A, and the dot will match the letter B, but then the anchor doesn't feel satisfied because we're not at the end of the string. And if we didn't have the caret in the beginning, right, this dot could match the B and this could match the C, but since we're anchoring this at the beginning and this matches the B and we're not anchored at the end of the line, there's no way we can match this pattern. If you put the $ in parentheses, I don't think it will put anything into the register. I've never tried that. But if you did, you know, paren $, I think you just end up with an empty register. Or it rips a hole in reality and we open up a portal to a parallel universe, one or the other. But I've never tried it. Regular expressions are really tricky things, right? Because there's ambiguity, right? In general, if you don't have anchors, right, there may be a lot of places that you could match a pattern. So, you know, if you search for, you know, A, B, followed by any succession of characters, followed by C, right? What's the proper way to match this pattern? Well, you know, there's an A, there's a B, there's a succession of characters. There's another A and another B, there's more characters, there's a C. This would actually gobble up all of this stuff. Or if you search for, you know, A, B, C, and you're a regular expression machine, right? You come in here and you say, oh, I got an A, good. I got a B, good. Oh, I don't have a C, right? And so you have to go back and you have to examine your string at different points and try different ways of satisfying this expression. And when you have wildcards, there's multiple options for how you can do this. So you can actually write like a whole tree that shows the different ways that you can parse this out. So if you've been taking CSE215 this quarter, this is what we've been talking about the past week, right? Is language recognition. That's, you know, what regular expressions are all about. All right, so swapping the first and last characters. So anchor is optional. Match the first character. Match the last character, anchor it at the end. But we've got to gobble up the stuff in the middle. And so we can match, you know, any succession of characters in the middle with a dot star. And that would match nothing, it would match one character, or it would match 100 characters. But when we replace this, what we're going to replace it with is, you know, this last character, followed by all the stuff in the middle, followed by the first character. So this middle stuff has also got to go into a register. And then we replace it with the last character, the middle characters, and the first character. All right, making sense? All right, we didn't open a portal to a parallel universe. So yeah, I think it just matches, you know, an empty string and puts that into a register. All right, cool. Let's try one more. Let's try So let's add an S to the end of any line that starts with a Q. All right, cool. Yeah, so seeing the right spirit here again too. Um, we can see if a string starts with a Q pretty easily, right? By just looking for an anchor followed by a Q, right? So beginning of the line followed by a Q, and we're going to want to replace that with the entire string followed by an S, which means we have to put the entire string somehow inside a register. So there's a multitude of ways to do this. Right, if we do this, this should match beginning of a line followed by a Q followed by any number of characters followed by the end of a line. And we could replace that with everything that we just matched followed by an S. We should be able to match the beginning of a line followed by a Q followed by any succession of characters followed by the end of a line, and replace that with, well, what do we want to replace it with? The original line followed by an S. Well, the original line was a Q followed by all those extra characters followed by an S. Or we could match beginning of a line followed by a Q followed by any succession of characters followed by the end of a line, and replace that with what we matched in the first register, which is a Q, what we matched in the second register, which is the rest of the line, followed by an S. And so different ways to do this, but the common ideas are, right, use an anchor to make sure we're matching a Q as the first character of the line, but pick up all the rest of the line because we want to put that into the substitution pattern. Now, if we just wanted to replace Q with S, right, we could just substitute /Q/S. But we want to take the whole input line and replace it with the whole input line followed by S. So we've got to have a way to get that whole input line in the replacement side of our expression. So that's why we throw it into a register. The registers are basically when you want to have something over here on the right that comes from your original string. Best way to do that, throw it into a register. So any of these should work fine. And that's mostly what I'm seeing. Again, syntax is always tricky, and that's just kind of trial and error to nail it down. But good. I think people have the idea. Yeah, cool. All right, we are out of time. We are past time. Sorry about that. Um, cool. So have a good afternoon. I will see you tomorrow. Tomorrow we'll talk about the final. We'll do a quick review, any final questions, and so on and so forth. Um, and then we're done. So all right, have a good one. I will see you next time.